as you can see, the Google Cloud Console is basically a dashboard whereby you will do most of your GCP configurations, and you have different services, and it's where you will configure your billing accounts. As you can see, you can view detailed charges, you can create and manage your projects there. You can create and manage all your projects regardless of the data center location you choose. So before using Google Cloud Console, you need to have a project. You need to have a Google account. You can create a new Google account if you don't have one, or use an existing one. And then you can go to the projects section and click create project, and this is where you will configure your project details, your project name, the billing account, and then the organization and the location. So because I had already created my own project, I'll just go back to it. So in the console, we have a number of services, as Oscar said. In the compute category, we have the compute engine, Kubernetes engine, VMware engine. In the serverless, we have the Cloud Run, Cloud Functions, which of course Oscar explained. The storage, the databases, Docket has Bigtable, NoSQL and SQL databases. And then we have the networking and so many other things, including the operations suite. We have big data and machine learning services. And one good thing with GCP, you have the getting started guides, which will give you quick start experiences right from inside the console. Yeah, so in the console, we also have the marketplace, whereby you can deploy ready-to-go solutions so that you can spend less time installing and more time developing. So with just a few clicks, you are able to create solutions with a single bill, and you're good to go. So there are so many ways that you can interact with GCP. The main and most common way is the Google Cloud Console. And another way you can interact with GCP is via the Cloud Shell. You can actually activate and run a single command to execute so many things that you want to execute. So the next thing we're going to do, I'm going to create a virtual machine. I'm going to create a Linux virtual machine and a Windows virtual machine. So I'll navigate to the left menu. Then I will go to Compute Engine, VM instances. Compute Engine lets you create virtual machines running in different operating systems, including different flavors of Linux and Windows servers. And you have the option of also creating custom images that you can import from an existing system. So I'll just go ahead to name my VM test Linux instance, because I want to do both Linux and Windows servers. And then I can add labels if I want to organize my resources in case I have many projects. And then next I will go to the region and the zone. I'll take the default region, US Central 1, and the zones basically help, especially if one zone goes down, at least it won't affect other zones, and you can continue running your applications in case one zone fails. So you can see this region has 4 zones. And then in the machine family, we have the general purpose, which Oscar explained, the compute, the memory optimized, and the GPU. So if you choose the memory optimized, then your VM will have way more memory per processor core than it would normally have. So I'm going to stick with general purpose, and for this I'll have a balanced amount of compute power and memory. Next, I'm going to select the E2 series, which is the default, which which means it will pick whichever type of CPU that is available. And then in the machine type, I'm going to choose the size of the VM I want. I'll go with the shared core E2 micro because it's actually cheaper and it meets my requirements for now. And as you can see on my right hand, there's a monthly estimate that is being computed as I provision all these resources. So yeah, one good thing with GCP is that you can get the monthly estimate as you go. And then the next thing I'm going to do is to configure the boot disk. I'm going to run a Linux Ubuntu server. So I'll just go to Ubuntu and then I'll configure the version 18. And then I'll configure the standard persistent disk. As Oscar said, the SSD is faster, yes, but it's expensive. And the balanced persistent disk costs more, a bit more. So I'll go with the persistent disk and then I will select. Then because I want to run a web server on this instance, I will allow HTTP and HTTPS. And then in the networking section, I'll just go with the default network in this instance. In the next instance, I'll probably show you how you can create a VPC network and configure it with your instance. And then in the disk section, you can add a new disk or attach. And then the management section, I want to add a startup script that will tell my instance to install a patch when it boots up or restarts. So I'm going to copy the startup script and just input it in the automation. So yeah, so this command will just tell my server to install a patch when it boots, and then I will just create the instance. Yeah, so as the instance is creating, I'll go to the Cloud Shell and try to create an instance with the same procedure, but using the Cloud Shell. Basically, Cloud Shell is basically a terminal that GCP provisions for you, and you can use it to create resources and change configurations with a single command. And one good thing about it is that for every action you do in the console, there's an equivalent gcloud command. So in this case, I'm going to create another virtual machine, but using the command line. So I'll just copy this. Yeah, so then I will authorize. And then I will say yes. Yeah, so as you can see, my test Linux instance is created in the Europe West one, and then the machine type is N1 standard. It's not preemptible, and then I have the internal and external IP, and the status is running. So if I go back to the console and I refresh, I can see both my VMs are up and running. Yeah, so that is how we create the Linux machines in GCP. So the next thing I'm going to do is I can SSH into my instance and probably upload a file. Yeah, so let me SSH into it. There are so many ways to SSH into it. You can use the normal default. You can open your server in the browser, or you can use public and private SSH keys, but I'll go this way. Yeah, so it's connecting, and the goodness with this, GCP transfers SSH keys to your VM. So it's also a secure way of opening your instance. So I can actually upload a file into this instance. For example, the Power IT logo, and then you can see it's doing a file transfer, it's finished, and it's telling me my file upload destination is in home, Diana. So I can close this, and then if I can see my sample file is already inside, and if I go to the present working directory, it tells me it's in the home directory. So that is how you can upload files into your instance. And having done that, we can go to, I'm going to review the VPC networks. Basically, VPC is a managed service that allows you to create VPCs, and a VPC is an isolated environment where hosted in Google Cloud Network Infrastructure, and inside your VPC you can define subnets in any region you want, and you can create resources inside them. So if I go to my VPC network, I can see there's the default network, which is automatically there. I can create a new VPC network. And name my VPC network test VPC network. You can add a description, and then I'm going to create an automatic subnet, because it lets it creates a subnet in each region, and then I will the dynamic routing, I'll leave it at regional, and then I will create. As my VPC network is being created, virtual private cloud allows you to create firewall rules also, so that you can filter any ingress of incoming and outgoing traffic, and you can block any unapproved network, any unapproved traffic. And subnets in different regions can actually communicate without transversing the public internet. So that is why it's the VPC comes in handy, because it helps us to have that private network away from the public internet. Yeah, so if I go to my test VPC, I can create firewall rules, whichever I want. I can add a firewall rule and name it allow RDP, because I want to use this subnet to create my Windows instance. And then I can put a description, and then for the network, I'll just choose the network I created, and then targets, I can specify that it targets all instances in the network. For the source ranges, I can say from anywhere, and then I will allow port 3389, which is the RDP port, and then I will create. Yeah, so as it creates, let me go back to my VMs. Remember, we had installed a startup script to install a patch on when my instance boots, and that is what I want. I want to test if my patch installed. So I will just copy my external IP, and yes, it worked. So the startup script helps, especially when you want to do some installation, you want to configure softwares, you want to run operating system updates, you want to enable services, that is why it comes in handy. And the good thing about it is that it's automated. Yes, so if I go back, I want to create a new instance, a new Windows instance now. And then I will name my instance test Windows instance. And then for the region, I'll just leave it at default. And then for the machine type, I'll give it a higher specs, because Windows sometimes needs has higher requirements for CPU and memory. And then in the boot disk, I'll change my operating system to Windows Server, and then change it to 2019. I'll change the boot disk to standard. I can do 20. Okay, I think 50 was okay. Then I can select. You can see the cost changed. When we were running a Linux instance, it was actually cheaper. Because when you're running a Windows server, you are charged for the license costs, and for Linux is open source, so it's actually free. But for Linux, you have to pay for the license costs. And then, and also what contributed to the cost is the specs that we used. In the other Linux machine type, we used the E2 micro. In this one, we've used the E2 medium. So this shows you that the kind of workloads you run has an impact on your costs. So we can also allow HTTP, and in the networking section, I can go and choose my network, which I created, because by default, the default network is the one which is there. So I'll choose my default test VPC network, after which I will just create my instance. Yeah, so my instance will take some time to create, and that is how we create a Windows instance. So the next thing we're going to look at is the backup and disaster recovery strategies that Oscar talked about. The snapshots, the images, the Google Cloud Storage, which come in handy when you want to have a strategy or a backup to go back to in case of any failure. So now that we have created the VMs, we can proceed to the data backup and disaster recovery concepts. So first thing, we're going to go to the snapshot. Snapshot basically is an exact copy of your disk that exists because it exists at a specific point in time, and it can even be taken when you're still reading and writing to your disk. So you can create a snapshot, and snapshots are very easy to use. So they are very good they're very good as backup solutions. And I can name. It's good when you're creating a snapshot, you need to give it a meaningful name. So for this one, I can just say test Linux instance. Then I can go ahead to create the date in which this instance was created, today 17th. Yeah, so you can also give a description. And then for the source disk, I'm going to choose my tests Linux instance. And then for the location, if you choose the multi-regional location, it means you want multiple redundancy. So I'll just go with the regional, and then the location US Central, and then I will create my snapshot. as my snapshot is creating, it's important to note that snapshots are incremental and they are automatically compressed. So that is why they are very friendly in terms of costs. And when we say incremental, we mean that when you create the first successful snapshot, it's in fact a full snapshot, and the preceding the other snapshots that you create will just contain the new data that has been written in the disk. It won't contain the data that is in the first snapshot. It will just take the new data that has been modified since the first snapshot. The same case applies to the second snapshot. Yes, and the third. So that is what we mean. So we've created a snapshot manually, but we also have something called a snapshot schedule, whereby this is the most recommended one. Because it enables you to set up a schedule and do a frequency, and you can attach your disks to the schedule and forget about it. So I'm just going to name mine test instance, test Linux instance. And then I will do the date. For the region, I'll just retain the US Central. I'll go with the regional, and then in the schedule options, you can decide to to schedule your snapshots either hourly, daily, or weekly. I choose to remain with the daily, and then the startup time, I can choose a time when there are no much writes and reads into my disk. That is 1 a.m. to 2 p.m. at night. And then you can choose to auto-delete snapshots after probably a week or 7 days or 14 days. That one is for you to decide. And then the deletion rule, I want to keep snapshots even after I've deleted the disk. This is because it can help, especially for disaster recovery mechanisms, whereby you've deleted the disk and you still have the snapshots there. Yeah, so I will create. Yeah, so that is how you create a snapshot schedule. And that is okay. Okay, let me go back. Yeah, so if I go to the snapshot schedule, it has propagated, and it's every day starting from 1 to 2. Then I will go ahead to attach the snapshot schedule to my test Linux instance. I will go and edit. Then I will choose the schedule I've created, and it will start every day from 1 to 2. Then I will save. And that is how we create snapshots and snapshot schedules. Yeah, so, and the next thing we're going to look at is images. Images basically are used to archive your application versions for disaster recovery, and you can even roll back to an instance if you have an image. So after registering the image, you can create one or more exact replicas of the original disk, and that is the purpose of creating the image. And you can use the operating system images to create boot disks for compute instances. So I'll create mine and name it test image. And then the source is the disk. I'll choose the disk I want to, unfortunately, you can't create an image when your instance is running. So I have to go and turn off my instance before creating the image. Yeah, so I need to go back to my VM instances, and then I will turn off one of my instances. I will stop, and then I will be able to create an image from there. So custom images basically can be created from boot disks, as we've said, and even other images, and you can use it to create an instance, and you can also use it to as a backup. Okay, you export your image to GCS as a backup strategy, though. Yeah, that is the purpose of custom images. Yeah, so we have stopped the instance, so I can just go to images and then create image. I can just leave it with the default name. Then the source is the test Linux instance 2. Then I'll choose the regional, and then I will create. Yeah, so that is how we create an image, and you can use the image to actually spin a VM. Yeah, so the next thing we're going to cover is Google Cloud Storage. Google Cloud Storage is, as Oscar said, is the object storage where you can store your content, web streaming content, etc. So you can go ahead to cloud storage. You can choose to use the command line, or you can just use the console and create a bucket. So your bucket needs a unique name. So for this case, I'll just name it Power IT Academy bucket. And then I will continue. So I will choose where to store my data. The location type has 3 aspects. There's multi-regional, and then there's dual, and then there's region. The multi-region is best for high availability, and then across a large area. Then for the dual is best for high availability and low latency across 2 regions. And then for the region one is best for low latency within a single region. So all this affects the cost, the performance, and the availability. For multi-region, you have multiple. You are considering multiple redundancy, but for the region, you're considering low. Okay, yeah, low redundancy. So we'll just go with the regional, and then I can choose my location. I want it to be in US Central. Then I will continue. I'll choose the default class. Classes are very important when it comes to Google Cloud Storage, because you can pick the storage class based on how long you plan to store your data and how often you plan to access it. So, okay, so the standard is best for frequently accessed data, nearline for data that you access less than a month, cold line, the data that you access less than a quarter, and archive for data that you access once a year. And you can actually set a life cycle policies and rules that let you apply actions to the different bucket objects when certain conditions are met. For example, switching data between the classes, so that you switch object to call the classes when they reach or pass a certain age. So we'll just remain with the default, and you can choose how to control access to your buckets. I'm just going to leave it at uniform control, because it allows only bucket level permissions. And then you can also allow public access or revoke it. Then you can actually enable object versioning. Object versioning lets you restore objects that you have overwritten or deleted. So you can choose to choose that option. Then I will create my bucket. So my bucket is here. I can upload files into it. I can upload a folder. I can create a folder. So in this case, I'm just going to create a folder and name it my first folder. And then I will upload files into this bucket by going to upload folder. I'll just go to this sample file, open it and upload it, and you can see a notification. Yeah. So that is how you can upload files to Google Cloud Storage for purposes of data backup and disaster recovery. Yeah, so finally, as we bring this to a close, I'm going to go through the identity and access management. Yeah, for identity and access management, this is basically a way of managing permissions on your Google Cloud resources. It lets administrators to authorize those who can take actions on different things. And yeah, so for example, you can let your developers have some permissions on certain aspects, and your finance people to have certain permissions on certain things. So in this case, we have permissions which are grouped into roles, and roles are granted to authenticated principals. By principals, we mean it can be a Google account, it can be a group, it can be a cloud identity domain. So yeah, so a role is a collection of permissions that you can give to your different principals, and then a policy is a collection of roles binding to one or more principals that you've given individual roles. So there are several kind of roles that you can assign people in IAM. We have basic roles, which are also called primitive, and then we have predefined roles, and we have custom roles. So basic roles are basically the basic roles, the roles of owner, viewer, editor, and these roles, before assigning them to a person, you need to be very careful, especially when working on very sensitive information. The most recommended ones are the predefined and custom roles. So if I add probably my colleague Mwaniki at Power IT, I can choose to give him basic roles, which we've talked about, the primitive roles of editor, viewer, and owner. But they are not the best to give a person, because it gives them very high, it gives them very many permissions to execute some tasks. So I'm just going to give Mwaniki probably a cloud storage admin, cloud storage admin role that will enable him to manage cloud storage. Yeah, so if I give Mwaniki environment and object storage object administrator, he will have full control of Cloud Composer environments and cloud storage objects. Then I will save. I can also decide to add a Google group. For example, our cloud IT cloud Power IT group and give them some permissions like compute admin. This means they only have full control of all compute engine resources, and then I can save. So that is how we can create basic roles, predefined roles, which give us much fine-grained access to cloud resources than basic roles. And then we have custom roles, which you can create to tailor permissions to the needs of your organizations, where predefined roles don't meet your needs. So basically, that is how we go about the cloud identity and access management. So going back to our VM instances, we forgot to log into our Windows instance. So that is what I'm going to do. Compute engine. Yeah, so with our Windows instance, what you can do, you can just set the Windows password, and then username, I can just leave it to be Diana, and then I will set the Windows password. And then this one is so hard to memorize, so I'll just copy it and save it in my notepad. And then I will use the Rdp connection to be able to access the Windows instance. I'll take the external IP of my Windows instance, and then I will just copy it, and then I will connect. So I'll use a different account. The username was Diana, and the password was that one. And then I will say okay. Yeah, and it will open my Windows instance. Yeah, and that is it. Yeah. So thank you so much. We've come to the end of the demo. In case of any questions, and you can just ask. Thank you.